Hey, hello, hello, hello. Hello, everyone. Welcome to the Java Champions Conference, right? So it's a place where you can come here and you can talk to amazing Java champions. And today we have a top Java champion, good friend of mine that's here. Okay, I can see that we're live already. So, if you can hear us, you can say anything, just say anything in the chat so we know we have a conversation. There's lots of people already watching this here. So I see Jasper already here on the chat. So, hey, Jasper, how you doing? And yes, Stockholm next week is going to be J Focus, right? So good to have you all here. So, look, today we have a very special guest, right? This is a good friend of mine. I love to meet him when we are in conferences. I love to be to hear him talk. I see Billy. Hey, Bill Fly. Hey, Bill. That's good. And he's already here in the chat, right? So, without further ado, let me call the Java champion, Google develop expert, computer scientist, passionate computer science, right? Cloud Docker captain. I mean, he's everything. Public speaker. And he's also a Java group leader, Rustan Mehemedov.
Hello, thank you. Thank you for the introduction and thank you for having me. It's great to be here. So thank you again, Bruno. It's always great to see you at different events. It's always great to meet you in general, and it's really happy to have you as my host today.
Thank you so much. Thanks. So, Rustan, you're going to be talking today about cloud native, right? And I think that's one of the big things. Every developer should be thinking about the cloud, right?
Mm-hmm. Yes, exactly. So we can't really avoid cloud now. And even if you're not on the cloud, you still need to think about making your things, cloud native, it's called. You can also call it like cloud ready, because at some point you might go online to cloud services, some different kinds. It can be public cloud, we'll talk more about this, but it's can also be on-prem, because a lot of positive things that it brings, you can get benefits of that just without even just going on deploying it to public cloud, what you would typically think when you talk about cloud, right?
Yeah, that's why I think the cloud, when you talk about cloud, is not only the cloud, right? It's all the skills around. And I love that you're going to be talking about tools, right? So I'm a tools guy, right? So, I think it's amazing. So I see Michael here saying hello. Hey, Michael. So,
hey, Michael.
Yeah. So without further ado, guys, I want you to answer to ask all questions. Make sure this chat is full of questions so we can keep here learning from Rustan. So without further ado, with you, Rustan.
Thank you. Woo-hoo. Oh, that's nice. It's always fun to do, online talks where you're actually talking to a little thing in a little tiny little lens up in there, and you don't have the audience, and it's always more. That's even more important, to have a little crowd in the chat, and then you can actually write and comment. So I can actually see the clouds. Hi, Vincent. Hi, Michael. Hi, Jesper. All of you. It's really nice to see you all. I see your chat over there. So if you have any comments, anything, I'll try to keep my eyes on it. If I do miss some of those things, I really hope that Bruno can help me as well with some of those, if I happen to miss some of them. All right. So let's talk about Cloud Native Toolbox and what it is and why, and all this kind of things. And like Bruno said, my name is Rustam. I am based in Oslo, Norway. I have been working as a consultant and also as an in-house developer for since 2006. So it's almost 20 years now. This is a bit of a mix of my experiences and all this kind of things. And one of the things I wanted to talk about is what is different, like what is really different from the way we used to do applications before, and why it is a different thing. So I'll be kind of referring a bit to good old days, if you may say so, so, and then we'll talk about that. But usually when I talk about talks related to cloud and cloud native and all that, I kind of like to talk about what does it actually mean. And the fun thing I usually do. Well, I think it's fun. I mean, you might not think it. I kind of hope you do. But this is me uh, doing some, having some downtime and drawing some things. So as you can see, like there's a lot of drawings, tiny little kind of sketches and stuff like that. That's me just jotting things down. So um, I like to start with this picture, and this picture was originally made for. We had an internal thing at work, something called Inktober, where you would just draw things every day and stuff like that. And that was a picture for a word confusion. And I had like a series of cat series where I would just draw cats in different kind of things, doing different things and depicting different kind of words. But this was a word for confusion. And then I thought, I might just expand this picture and make it a little bit more in a fun way to explain what cloud really is. And you might have seen that joke before. If you haven't, then enjoy it now. If you have, well, bear with me for a second. So what is actually cloud, and what is really clouds are made of? And then you have a dad explaining to the little cat what actually clouds are made of. Well, it's mostly Linux servers. It might not be the same cloud that the little kid cat was, or kitten, or whatever that I drew, was thinking about. But yeah, it's mostly Linux servers, and it's, in case you wonder, it's a tiny little penguin there. At least my attempt to draw a penguin. But what is actually cloud native, and what is actually cloud? Well, if you say it in a different way, another kind of thing that you've seen probably quite a lot of places, but yes, it's been used quite a lot, but it still explains and kind of conveys the picture quite well. Cloud is not really something mystical. It's basically somebody else's computer. It's just managed computer by somebody else, or a server. Another way, like, so jokes aside, like in drawings and all that, I'm going to do something totally different. I'm going to show you a wall of text. And that wall of text is actual official definition of cloud native by CNCF. There's a reference down there to where it actually taken from. And yes, it's a wall of text. Yes, you're not supposed to show it on the slides. And yes, you probably are deep into reading and parsing that text and trying to understand. Please stop. I will help you with that. Don't worry. So the way I will help you is just, I'm going to highlight some of the words that are kind of important and central here and that we'll be talking about. I'll remove all the other words. So now it's a little bit more, it's a little bit easier to process, and it kind of looks almost like a word cloud. Yes, pun was kind of intended. And so, but still, it's a bit of a big mess of words, right? So what we can do about it is that we can actually make those words a little bit more easier to digest. So now this makes hopefully a little bit more sense. This definition talks about what we're building. We're building scalable applications for public and private and hybrid clouds and all these kind of things, right? We have an explanation of how we're doing it. Well, we're going to use containers, we're going to use service meshes, microservices, immutable infrastructure, all the fun things, all the buzzwords that you've heard probably quite a few times at different events, conferences, blog posts, you name it. And the last part is, why are we doing it? It's apart from it's fun to do all these kind of things, apart from, if you don't think of, what should I say, like a CV-driven development or, conference-driven development. This is actually the reason why we're doing it, like the actual reason, because we want loosely coupled applications. We want to be resilient. We want them to be manageable, observable, with a bunch of automation and all the fun things. We want our applications to be able to change frequently, predictable, and with little or minimal toil. So a little bit less of boring stuff and more of fun things that we can do as developers, right? And again, this is actual definition of cloud native. So this is the actual thing. I did not really remove too many words. You can see if I go back, there's not that many. It's the kind of the filler words that makes things hanging together that has been removed, really. So with that out of the way, we can talk a little bit about more about why. So I want to start with why, and um because if you're doing something without any reason, then there is not that much reason of doing it, right? So we'll start with why, and then we'll get to the toolbox at the end, right? So we will spend quite a lot of time talking about the toolbox, but first I want to give you a little bit of motivation. And that being said, is that it's also important to mention that you are more than welcome to uh, you're more than welcome to actually write comments there, and I will read them, and I will stop and ask questions or read your questions, and then you can actually uh, yeah, there you go. Your questions will be on screen like this. Hello, hello. That's really cool. uh, but there is actually another comment from Bruno, which is, I love that I have the the golden circle. And this is, I guess, let me see, let me go back. The one that were, yes, Bruno, there you go. This is now, yeah, you're on mute. If you want to say something, you're on
And
screen.
I'm just saying that this whole thing about starting with the why, like you did, I think if I find amazing, and that's exactly the golden circle that I have
Exactly.
on my board behind me, right? Yeah. So
Yes.
I love this idea that you start with the most important. So
And you know why? I mean, this is like, I read it somewhere. So this is actually the best sales pitch that you can have. Like, I mean, if you're going to sell somebody a used car, I'm not doing that, right? Just for the
mhm,
record, I'm not doing that. But like, if you're going to sell somebody something, a car, or I don't know, a solution, whatever, you always should start with why. Like, hey, imagine you driving in that amazing car on amazing roads, and really fast and really, really something. And then you kind of get this feeling, and then you actually explain, well, you know what, you actually have to pay for it, and that's
mhm,
going to be expensive. And then so it's actually a good way of uh, selling, in quotes, idea
mhm.
to others, right?
Yeah, perfect. So that's amazing.
Yep.
Okay, I'm around
Thanks.
here.
Thanks for the comment. So that's really, really great. So if Yeah, there we go. There we have the circle again, so you can see it there, the little one, with why, um, with why, how, and what. So back to business. Let's go back to the why. So why usually means business needs, and I've seen it in many ways. I mean, like I said, I worked as a consultant for almost 18, 19 years or so. And very often I would go to customers, and then they would help us. They would need some help from us to develop something. And then they will say, they will bring some bunch of requirements, and then they will say, we all want you to do all that. And then, why, you would say, and then it would come with some business needs that they actually trying to solve. And very often it will be a very kind of similar set of things, and maybe in different wording, but very, very similar. So you might recognize yourselves in the same, in what I'm going to show you now. And if yes or no, feel free to comment again, and then I'll bring you up on screen. So first thing is often very typical thing. It's usually about the speed, and I'm not talking about speed of how fast your application is working or responding and stuff like that. That's a different story. But here it's more about speed, like time to market kind of speed. And that is, we have seen so many times where one company has an amazing product, another one has a little bit less amazing product, but that little bit less amazing product ends up winning at the end, just because this company with amazing products was a little bit slower to roll out new things and to listen to their customers, or adjust one way or another, while the other one was actually much faster, right? And this is an important thing. So we want to have an application that is easy to respond. Like, it's just for the developers to develop it, and then it's ready to be pushed, and it's going to be online and live for everyone and all this kind of thing. So that's one thing. Another thing that we often see is agility. And again, here I'm not talking about agility as in, agile and, sprints and all that. I'm really talking about responding to change. How fast you can respond to change. It's quite related to speed. So this is a bit different, but still the same. It's you should be able to deploy new versions. Typically, what if you translate it to a developer language, right? Agility, responding to change, should be able to release new versions easily. You should be able to make changes relatively easy. You should be, you would not need to have a really rigid and like waterfallish test regime. All these kind of things, right? So very often they would need that. Well, that kind of goes without saying, Captain Obvious to the rescue and all that. But, it's reliability is a thing, right? You really want your applications to be reliable. That's no point in creating an amazing application that will just crash every second time you call it, right? You want it to be stable. You want to be, reliable in many ways. So here we'll also see two related kind of points. So one of them is more about reliability in the sense that it's going to be there when you need it, meaning that it will be there if there will be only one user for using that application, or it will be there even if there will be like hundreds or thousands, or I don't know, hundreds of thousands of users there as well. So scalable application, available application, right? So you will not be losing a connection to it or losing access to it just because there will be too many users, or too many resources are being consumed in one way or another, right? I put actually testing and making sure that like a quality assurance stuff into the reliability as well, because, well, obviously without reliability or without testing, your application probably not going to be as reliable as it would be with some different tests on different levels, like unit tests, integration tests, all those kind of things. And all in all, for all of the things that I mentioned and I haven't mentioned, automation is a very important thing, right? So you automate some more. When you think you're done, you kind of take a little break, grab a cup of coffee or whatever your favorite warm beverage is, and then, or cold, whatever, and then you automate some more, because you always try to automate boring things and take them out of the picture so you can actually spend time doing fun things, right? Like I said, this is the second side of the reliability. I kind of decided to split them up. So one of them is about like scaling and automation and availability and all that. The other one is actually resilience. So how do you respond to things going wrong? So one is making sure things do not go wrong, but it's I don't know how about you, but most of the developers thinks they never write bugs, but I do sometimes. Probably, like, I don't know about you, but most likely you have done it at least once. And that is the other side of it, right? Now we have to be able to gracefully handle if something happens. It's really not a question of if, it's more a question of when, right? If you write really amazing code, it will probably happen less often. If you write, even more amazing code, it will happen even less often, right? But it might happen. Maybe it's not you, maybe it's somebody else. Usually is. Maybe it works on your computer, maybe it doesn't work on something else, all those things, right? Actually, we'll talk about this works on my computer thing as well in a bit. So fault tolerance is an really important thing that kind of differs very often from the old way of developing applications, and very often your customers, your product managers, your whoever is paying for you to develop your software would really appreciate that, right? So fault tolerance, that means reacting in a good manner when something goes wrong, something inside your code, something outside of your control, something in between. It doesn't matter. You should be able to handle those things and fail gracefully. Same thing goes with for observability, because observability is more about being able to look into those little containers somewhere running somewhere, or your application inside of it, and see how it feels and how it's going. And the reason you want to do that is, well, there are several, but sometimes it's a good way of being able to see how your application is doing and knowing that it might break before it actually breaks. And sometimes you just want to have some statistics and tracing and all this kind of things. Obviously, security goes under the resilience as well, because, if your application is full of gaping security holes, it's probably not going to be very resilient. It's not going to be, people will do some stuff to it. I don't know, SQL injections, takedowns, whatever, right? You don't want that to happen. And the last thing that is, and that's a kind of a fun thing that is being quite often, I would say, misunderstood. It is something called lock-in, and like vendor lock-in, all these kind of things. And people tend to exaggerate that quite a lot. And people who don't know technology very well and maybe have some understanding of it without like understanding or knowing the details, they would kind of think of lock-in in a different way. But the way I think of it is that if you're using open standards, if it is standard supported by more than one provider, it's most likely you're okay, because you will be, if you define lock-in very, very, very in a very rigid way, by just starting to write your code, just writing the first line of your code, you're already creating a lock-in, if you really think about it like that, right? You choose a language, well, that's a lock-in, because you can't switch to another language. Or you choose a framework, oh, well, that's a lock-in, because then I cannot change to another framework. But the question is, like, is this really a thing, right? How far up or down do you want to put that lock-in threshold thing? I've seen some really, really extreme cases of that, where people would say, you know what, we cannot use this managed database service by a cloud provider. So there is a cloud provider that provides a managed version of a database, which is a standard open source database or compatible with that, like MySQL, Postgres, all those kind of things. People would be like, no, we can't use that. We have to create a VM, install our own database, run everything on that thing, and that is. But why? Well, because otherwise it will be locked in, because it's going to be on the cloud by cloud provider X, and then you have to really kind of take a few steps back and see, like, do you really want to manage your database? Do you really think it's going to help you? What are the chances for you to switching to another database, really? I mean, maybe it's a good idea, but does it really worth it, spending too much money trying to make it possible to move? So this is a little bit about business needs, right? Next thing I want to talk about is the what, right? You remember we had this, I did put up in a corner there the reminder of different parts. So we had why here, right? And now we have what. And what are we building? Well, we're building scalable applications running on public, private, or hybrid clouds. And I'm going to go real quick through this definition, but just so we're on the same page, because there are different definitions, different understanding of this kind of thing. So I'm just going to do a very quick recap of this. So cloud, typically public or private. That means that public cloud providers, that's like, I don't know, Google Cloud, Azure, AWS, all the other ones as well. It's typically an offering available to everyone. And you can also run a cloud, private clouds, so they're not open for everyone, but only for your company, maybe for like a group of companies, or I don't know, a network of universities, whatever that might be, right? So it can be public and private clouds, but still managed by somebody else, right? A bunch of computers and servers. Um, then we can have multi-cloud. Multi-cloud is where you combine different cloud providers in one solution. You're using several of those. The reasons for that can be very different. It can be sometimes it can be uh, because your application is super super important and very critical. You really need to have failovers across regions, across data centers, regions, all that, but also across cloud providers, because if something happens to cloud provider one, you can always redirect all your traffic to cloud provider two, and everything will be smooth, and not users will not see any difference, right? But then again, most of our applications that we're developing are not that critical that we really need to spend money and resources creating those multi-cloud solutions. What more likely to be the reason for your multi-cloud choices, or choice to go multi-cloud, would be probably pricing, because some things will be cheaper in one cloud, some things are cheaper in another cloud, or maybe even available in another cloud only. And then you need to be able to pick and choose. You want to do, okay, I'm going to do data warehouse in this cloud, then I'm going to do machine learning on another cloud, then I'm going to do CPU and VM and all those kind of things, just renting hardware in the third cloud. And together I have an amazing solution for users. It's seamless and it's not visible. For me, it's visible in my bill, right? Last thing is a hybrid cloud, which is a mix of a cloud, whatever that is, public, private, whatever, and on-prem solutions. And again, reasons for that very often would be something like privacy, where you're not allowed to take data out and put it into a cloud, or maybe it can be very specific hardware requirements. So, for example, things like where you, uh, let's say you have a very very special solution that needs very special kind of hardware, like graphic cards or something, to run, and that hardware is not available in the cloud. What do you do? Well, you can combine your on-prem solutions, your on-prem racks somewhere in the basement of your building or somewhere, and with the cloud services as well. So that is the what. Now let's talk about the how. And this is kind of, we're getting very, very close to the toolbox. And um, like I said, I'm going to say it again. You're more than welcome to comment on things in the chat. And also, when by the time I get to different parts of this presentation, I would love to hear your thoughts. If I'm missing something, if you want me to add something, or all those kind of things. Okay. Vincent is saying a cool certification to start with a cloud native is Kubernetes and Cloud Native Associate. Yeah, that's really nice. Yes, that's those kind of certifications for by Cloud Native CNCF, and also by different cloud providers. If you want to learn more about how you do it on a specific cloud, those are really, really good. So thanks, Vincent. That's a very good way of starting with an understanding how things are and how things work, really. Yes, opportunity cost is also, I guess that was the comment to the business requirements, or like what people, yes, that was yeah, I know what that was. That was probably the comment to the time to market thing. And yes, I agree. I agree on that one. Let's see. So how? Let's go to how, and keep. Thanks, people. Keep. I see there's quite a lot of you on the stream, so keep writing your comments, and I will put them online. Okay. So how? And how is about containers, service meshes, microservices, immutable infrastructure, declarative APIs, all those kind of things, right? First of the thing is what we've heard for ages now, like since we've heard this new amazing thing that's going to save the world and make computing world so much better, called microservices. And all the breaking up of the monoliths that we were supposed to do and that we have been doing, it's been loose coupling. And loose coupling it's a really good thing in many ways, but it also requires some work from your side. What kind of work? Well, instead of creating a monolith, now you have to have a bunch of microservices. Some people might even go totally overboard, and I've seen that happen, and create nano services, not even micro, but nano, tiny little ones. And those are not a very good idea to create, because those are really pain point later. So it requires from you to be kind of uh, to be on the lookout to how to split up things. When you split up things, you have to decide if it is too big or too small, and then you need to kind of regroup and redecide and make changes, right? And yes, Simon is saying, or the joy of microservice design without resilience for J or a dedicated solution. It's really fun that you mentioned resilience for J, because spoiler alert, we're gonna talk about that. That's really cool. Another thing that, when you're creating loose coupling, you need to think about is architecture. You all of a sudden, things are a bit more loose. Things may disappear or may go down without other things going down. So now you have to design things in a proper way. You have to design your APIs. How do you design your APIs? How you build up your APIs? What is the standard for communicating? You're going REST, you're going SOAP, you're gonna go with RESTful-ish something, or you want to go with formats over HTTP, gRPC, all those kind of things. And security. Obviously, you need to do all this. Now that you have a bunch of containers talking to each other, you need to make sure that the communication is secure. You do TLS, you do encryption, all these kind of things. Now you all of a sudden you have a need for things like sidecars and all these kind of fun things. And when you do that, then you need to introduce some kind of service mesh, and then you have a full party going, right? So there's quite a lot of things to think about. We need some help and tooling for this kind of things. Right, next thing, let's talk. We're going to have 5 things here as well, and then for each of those 5 things, we're going to talk about tools for each one of them. Well, the second one is containers. We've heard about containers for quite a few years. I guess we're getting close to 10-ish years. People have been talking about containers, and very often they would talk about, as one thing or another thing. But to me, it's actually 2 things. It's about predictability, but it's about predictable 2 things. So you remember I mentioned works on my machine kind of thing? Well, containers make sure that it's not only works on my machine, because typical answer when people say that, if they say like, oh, works on my machine, it's like, okay, cool, then we ship your machine. Cool, just give me your machine, we'll ship it, we'll put it in production, and you'll never see it again. And then people will be like a little bit more protective, and they try to hold on to their machines. Containers kind of help you with that, right? The containers are about predictability, but they're about predictability of 2 things. One is to make sure that if it builds on one machine into a container, it can also build on another machine with similar architecture. If there are 2 different CPU architectures and all this, you will need to do some stuff to make them compatible both ways. But apart from that, it will be a predictable build, right? But it's also about predictable deployments, which is kind of more common thing for people to talk about, where they very often they talk about containers. They just think about shipping containers, deploying containers, and all this kind of things. But yes, it's about the predictable deployments as well, because if you know that, okay, it runs on my machine, it builds on my machine, and I can actually also make it available, and it just deploys in one environment, maybe let's say test environment, it will be also fine with the same container and same contents and all these things in production environments. It's also about security, because you can, if you're using the same container, you can test it, you can sign them, you can do a lot of like binary verification, all those kind of things that also make sure that those containers, nobody did put anything extra into those containers, right? They're kind of locked. Well, ironically enough, that's the image that they chose to use at the bottom there is unlocked lock. But that was about portability and vendor locking as well. Because if you can deploy a container, it will make sure that the solution can be deployed on another solution that, or another cloud provider, or another anything that can run containers as well, with very, very minimal or no changes at all. All right. Number three. Number three is automation. We talked a little bit about that already. I mentioned that you should automate all kind of things, and automate some more afterwards. I'm going to repeat it again. Automate, automate, automate. And I really mean automate all kind of things. And it's like, it can be automating boring tasks. It can be automating a bunch of tests. It can be automating deployments. It can be automating builds, all kind of things that you don't really want to do, or maybe do more than once. You should try to make once. It's a bit more extreme, but maybe at least like 2 or 3 times you should probably try to automate. It will save you some time in the long run, right? Sometimes I know that we developers have a tendency of trying to automate some things that will never run again, and then doing it manually would take us 5 minutes, but then we spend like, I don't know, 3 hours trying to write an amazing, beautiful script that can be very extendable and automating everything, all this kind of really nice things, and then you never run it again. That's another side of it. Try not to do that, but most of the times as a developer, especially in a like enterprise environment, most of the things you will be doing more than once, so it can be a good idea to automate things. Automating builds, automating tests, running tests, security checks, all those kind of things. Deployments, that's really, 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 really time saver. Like, there are few things that feel better than where you just commit your code, push commit, put it into right branch, and then it just automatically deploys into your test environment, production environment, or anything, and you don't have to do anything. You just have to wait for another 3 seconds, and then it's like, boom, it's there, and it feels so good. I don't know about you. For me, it does. I'm pretty sure that I'm not alone. Right. Next. Please, yes, I will give Podman some love, Simon. Just give me one more, 2 more points. So 4 and 5, and then we'll get to Podman and all the friends of that little, what's that, seal? I think it's a seal. It's something really, really fun, nice, little cute animal. To be fair, many of us have also been burned by, it's just a POC demo, don't spend time on polishing it further testing. Okay, yes, I totally agree, and I'm just thinking of how should I ask that question. Like, put up a hand if you have actually created POC that actually stayed POC and didn't make it into production. I would be surprised if it would be very many hands. So feel free. Please prove me wrong. I'll be very happy for you. Most of the times it will be exactly like Simon's saying, like, hey, it's just POC. Just do it quick and dirty, and then we'll have some time to fix it. And then you do it quick and dirty, it works. And then people would go like, but it works. So why do you need to spend more time on fixing it? No, we don't. Like, it's fine. We just need you on new features. We need you on another fire somewhere to extinguish that. So, just let it be. It works now. And then they call you back 2 days later, and it's like, hey, it stopped working. What happened? Like, why did you write a broken code, or why did you deploy a broken app? and then you have fun explaining things. So yes, more microservices implies a more dull CI/CD infra task. Exactly, and that's we're going to talk a little bit about that as well, because um, you have to do a lot of CI/CD, but also you need to, all of a sudden, you want to have a proper infrastructure for managing all that, because now all of a sudden it's not enough with Kubernetes, because it's not that fun to write kubectl, deploy and apply and all those kind of things. Now you want that to happen. You want to automate that as well. And now we're talking about a developer kind of deployment platform, or a platform as a service, all those fun things. So yes, I totally agree what you're saying. And um, so yeah, great, lots of great points from you, Simon. Thanks. So let's talk about resilience a little bit more now. So the resilience thing is, that's where we're going to be mentioning, well, spoiler alert, that's where we'll be mentioning resilience for J and all those things. But it's about, like I said, it's about handling errors and making sure that when something breaks, it doesn't take down the rest of your application. We've seen a lot of examples where things will break somewhere, and the other parts of your solution will try to get information from that, and then they don't get it because it's down, and then they will do retries and retries and retries, and then more things will start retrying, and then you have like this cascading effect of things breaking because you end up DDoSing your own application. That has happened quite a few times. I mean, it still happens quite a bit of times. So then, you need to be able to have some tooling, some libraries, some stuff that will do something with fault tolerance, something with exponential backoffs, something with handling errors, something with handling to have a failovers, so failover solutions, all those kind of things. You don't really want to code those things by hand. So we'll be talking about tools for that as well. We want some observability, because we talked quite a bit about observability. I'm not going to repeat myself now. Security and all those kind of things. Last thing, and that is that's a bit of again, like my fifth points are often a bit more things that need a little bit extra love and a little bit more um, getting a little bit less misunderstood. And in this case as well, it used to be actually called, in my early versions of this talk, they used to be called serverless. I changed that to scaling because I don't want to limit that to serverless really, but it's all about automating scaling to scale up or down your application because of some resources being too scarce or too many of. It's about maybe if you want to do serverless, that's cool. Maybe you don't want to. It's about sometimes scaling to zero, sometimes scaling to infinity, or to at least very big numbers. It can be a lot of different things, but it's all about scaling and deciding what is good for you in your application. It's about cost reduction really as well, because when you're scaling things up when you need to, well, you have to do it, so that's fine, right? But when you need to scale things down, or where you can scale things down, you really want to do it, because then you will be saving some money. And we also talk a lot about nowadays about sustainable development and all this kind of thing. So what I usually have a kind of, I'm full of bad jokes, and this is one of the bad jokes that I kind of have. It's like, if you're thinking of scaling and thinking of automatically scaling down, you have to think about one or of two green things. One of the green things is obviously money, because, well, you will save money, right? You will use less resources, and you will use less money. But the other green thing is, as you can probably guess, is environment, really. Trees and green stuff, because by using less resources for your application, you'll be using less energy. Less energy means less CO2 and all this kind of things to run data servers. And if everybody thinks about that and do it a tiny little bit for a tiny little bit of their applications, in a big picture, in the big numbers, it will actually matter quite a bit. So that's really nice. Let's see. I want to read some comments. So uh, developing a proper toolkit for automating the deployment stuff. And then okay. And then related to being burned by business, a good product owner asks you to do the double with the half. Of course, that's. I mean, any that they does it ever not happen? That's a really good one. Yeah, exactly. I mean, you're saying that you're involved in a lot of those discussions lately. I mean, if you have worked for a bit and if you're working as a senior in any senior role in a software industry, you probably have had those, if not daily, definitely weekly, probably daily as well. Those kind of discussions. It's kind of interesting. Yeah, exactly. So Ko is another great guy and Java champion, and also a guy that you often see at different events and stuff like that. He has a really cool presentation on green IT. So yes, go watch that one as well. It's really really it's a really important topic, and it's like, you might think like, oh, but my tiny little app, it's not very important. It's going to be like a little drop into the sea or ocean or whatever. It's not going to make a difference. But if enough people do that, it will actually matter. So do that. Right. But also scaling automatically things up and down also means less toil. So you don't have to think about scaling. You just, you set some limits, and then it will kind of automatically adjust depending on traffic, CPU usage, memory usage, whatever is important for your application. You probably know by then like what makes your application go slow or fast or whatever, or makes your application scale. The challenges here is something that we need to be able. That's a different talk. I have actually a different talk, and I'll be also doing a workshop on the same thing in Stockholm in a week. It's about optimizing your startups and generally your application, but especially your startups of your applications, because when you're scaling, especially if you're scaling from zero, no user nowadays will wait more than a few milliseconds before the person expects an answer. So you really need to make sure your applications are quite fast to start up. But also same applies if you're just scaling from, I don't know, let's say one container or maybe 10 containers to 10 or 20 or whatever, because the same thing, if it will take quite some time for every application to start up. I don't know, let's say minute for each application to start. That will take forever. Most of the users will be gone by then, right? So it's all about also writing your application in a way that is quite fast and easy to start up. But does it need to be an application? Is a fun question. Serverless functions can save a lot of. Yes. So serverless functions is a really nice thing. But again, it depends on the usage. So if you're really like, I'm talking about the actual applications or microservices doing things, but definitely cloud functions like lambdas or cloud function or whatever the things are called is a very, very good option for very small things. But then you have to make sure that it's tiny, it's very small, and you have to make sure that you don't have too many of those as well, because when there's too many of them, you're going to lose control of them, and you will have some weird stuff, old versions, dead endpoints, running zombies somewhere costing you money. So I really love cloud functions and like small functions like this, but this is kind of the downside of it, that you really need to be able to have a good control of them. You have to have a good way of deploying them, also automated, not point and click and copy paste piece of code, but also about actually the life cycle of those and actually taking them down. The solution is serverless for scaling, but might also not always be cost effective. That's a very good point as well, because so what Vincent is saying is that for cloud providers, so cost effective, not cost effective, can be in different ways. So the way I see it is that one is that it will be priced differently. For example, a lot of providers would give you a sustained usage kind of discounts. So if you're renting CPU and memory and disks and all that over a long time of period, non-stop, they will give you some discounts. When they also expect you to be able to use those, or you kind of renting resources that do use those constantly, they will be a little bit cheaper. If you're going with serverless, those things might be priced a little bit different because maybe a little bit higher up. So if you have a solution deployed 24/7 on a serverless platform, or on something that is made to be running all the time, you really have to think about the pricing, because very often the pricing will be a little bit different. But also another part of the pricing or cost can be that it might take a little bit more time, a little bit more effort to create a proper serverless, stateless application that can scale easily, optimized, all those kind of things. So there is a lot of things that you really need to think about that will drive your cost in one way or another. But if your application is being used sporadically, sometimes, amazing, it's probably going to be cheaper. But what I would suggest you to do is to use calculators, because most of the cloud providers and things like that, they would have calculators that will let you do that will let you calculate based on your usage, your use case, and they will give you a price based on that, and then you can compare it for yourself. But a last thing I say before we go to the next slide is that now we talked a lot about cloud providers, meaning public clouds, but scaling and serverless and all that can be also done on-prem. So you can do things like, actually, we're going to talk about that in a bit, about the tools, right? And next slide. But remember that you can also run serverless applications on-prem. You can put a bunch of servers, install Kubernetes on top of them, add some more fun things, and then you'll have all of a sudden a serverless solution as well. We'll get back to that in a second. Let's see what there is. Anything? Yeah, already 50 minutes. I know time flies really fast, but it's fine. We have time. All right. Invest in observability. Measuring is knowing. Yes, exactly. That is a very, very important thing. And tracing and observability, because now you have microservices, you need to trace your stuff as well. All right. Okay. So remember 5 things that we talked about here? You'll see 5 same pictures, exactly the same things, but now with tools instead under. So loose coupling. Loose coupling, it can be on, like, I look at it at different levels. So if you look at loose coupling from the point of like a code and technical dependencies between packages inside code and stuff like that, I would suggest you to have a look at things like PMD, JDEPs, and all those kind of things, because they will help you to understand how your different packages inside your application, inside your code, are connected with each other, how they're doing things, and avoid circular dependencies, avoid things being dependent on each other and back and forth, all this kind of messy things. Loose coupling also means that you need to handle, like I said, the security, encryption, all those kind of things. For that, you need service meshes. So typically you would like to go with something like Istio or any other service mesh. And then you have, for example, Kiali. Kiali is a really cool tool, open source tool. All of the things I'll be mentioning here are open source. There are a bunch of paid version of things as well, managed versions of those things as well. But here I'm going to focus on things that are open source. So Kiali is a console for Istio Service Mesh, which will well, help you to visualize things, to visualize traffic, visualize all those kind of things. Um, so you might want to combine it with Istio. And Istio doesn't have to be, we'll be talking more about service meshes in a bit, and where I'll mention all the other, or at least a few more other service meshes as well. When you're doing loose coupling, it's important to have APIs. Remember, when you have APIs, it's very important to document them. And it's very important to document them in as close to your code as possible, because the moment you copy paste it to some kind of wiki, Confluence, whatever thing you're using, uh, Word, whatever, HTML, Markdown, if you copy paste it to something, it will be already disconnected from your code. Every time you make a little change in your code, you have to remember to update those. And usually people don't. People forget on doing that because it's not that fun. So OpenAPI and Swagger and all those kind of things. And Swagger is built on top of OpenAPI. So OpenAPI is a kind of a REST endpoint that will give you a programmatic kind of view of all that, and then you can have a GUI on top of that, or UI on top of that, that will kind of show you as a Swagger as we know it. There are also ways of testing things now that you've put things into container, faking things, testing things, creating kind of disposable containers of things like databases and stuff like that. Now we need to think about test containers, things like that. We need to think about being able to respond to load testing and all this kind of things. So that's where things like Gatling come in. JUnit is unit testing, but there are a bunch of other unit testing frameworks as well. But just to mention some. And yeah, Wirework is also a nice facilitator. So there's a way of doing things, right? And then what else? Containers, right? So some of you guys already asked me to give Podman some love, and I will give Podman some love. I will give Docker, Rancher, Kubernetes, K9s, all this kind of things that can run containers some love, because you might want to use one or the other tool for that. There is Docker, there is also Kolima, Podman, Rancher, pick one and try it. If it doesn't work for you, try something else, all this kind of things. And what else? So Kubernetes obviously is the way of deploying and running your containers in a bit more managed way. Then you have like a little ones like Minikube and all those things for local development. K9s is a kind of a really nice console to manage all that on top as well. Back to service meshes. So we mentioned already Istio. There are things like Linkerd and all the other ones that will help you with managing all the certificates, rotation of those. Let's encrypt, all the fun things. Traffic, kind of traffic direction and ingress, egress, all those things that you really now all of a sudden need to think about and have some kind of understanding and control of. And most of the times you will need Kubernetes and you'll need some kind of service mesh. Automation, it can be very many things. It can be automation of builds and deploys, but it also can be automation of local builds. So, things of like, speaking of deployments, well, typically, let's say Argo CD, GitHub Actions, Cloud Build, there's a lot of different ways of doing it. Every cloud provider has their own local way of deploying things. Then you can also go with a bit bigger orchestrators. If you want to go a little bit more old school, if I can say that, you might want to go with Jenkins, like have your own Jenkins server. A lot of people don't do it anymore, but if you want to, sure, maybe you have a good reason for that. And then you have things like local builds or compiling and building your stuff. For Java or JVM world, that would be either Maven or Gradle. If you really want to go with Ant, sure, I can mention Ant as well. But for other tools, that will be for other languages, frameworks, and platforms, there will be something else. But you need to automate, and you need to automate a lot of things. And probably here under automation, I can also mention that a lot of those tools will also run your tests automatically, and and deployments and all those kind of things. Right. Again, please feel free to put into the chat whatever you think I'm missing for each of the categories. Yes, I mentioned WireMock already. I mentioned that comment from Simon already. That's really great. Thanks again, Simon, for a lot of good inputs. I want to talk about resilience. So some of you, I don't remember who that was. I think it was Simon actually as well, or it was Vincent, mentioned resilience for J. And the resilience for J is pretty much the kind of the cornerstone for a lot of things that we, yeah, there you go, Simon. Yes, thank you. And that was resilience for J is kind of a cornerstone for a lot of implementations are built on top of that. So there's a microprofile fault tolerance spec and implementation of that spec that is very often relies on resilience for J. Spring Cloud has that, or Spring Boot, all those things. People have been mentioning observability. That's very, very important thing. Then you have things like OpenTelemetry, Micrometer, Yager for tracing and all this kind of stuff. You have to collect all that data, to collect all those metrics. You have Prometheus. You have Grafana. You can connect Grafana with Loki. Tempo alerting. So Loki is for logs, and Tempo is for like time series, time sensitive stuff. Alerting. Well, alerting is alerting. Creating alerts based on something when something goes wrong. Since we're talking about security and resilience and all this kind of things, obviously we need to talk about security scans. There's a bunch of providers that do that. There is static code analysis, things like SonarQube and all that. There is cloud providers that do some security scans of dependencies and artifacts and code and containers and all that. There are third-party providers that integrate with cloud providers. So there's a lot of ways of doing it. I'm not going to sell you one or the other because I'm trying to kind of stay very independent here. But you can use one tool or another. There are things of handling secrets. That's also an important part of security. Don't put your secrets, your keys, your passwords, and stuff like that inside a container, because if that container gets somewhere, stolen somehow, they will break into it and they will find those and they will use those against you. So use security managers on the Kubernetes deployments and all those kind of things to handle those things as well. Right, and the last thing is about scaling, as we talked. Right, there is different ways of doing that. So one of the things that I really want to mention is Knative, that I've been kind of mentioning without saying the name already quite a few times. When I remember I said that you can do serverless on-prem. Well, that's Knative. So Knative is you take Kubernetes, you take service mesh on top of that. It used to be Istio. Now I do believe it's still Linkerd. And then on top of that, you install Knative, and it can come into flavors, so it can do event-driven or a bit more kind of a traditional kind of way of scaling up and down things. And Knative, that's what it does. So it will let your applications to be scaled up and down automatically without you thinking about it, without you managing it, without you doing anything really. And you can also do some fun with traffic and all those A/B tests, and redirecting some of the traffic to new deployment, new version, and then keeping some of it to the old ones. All these fun things that you can do would be able to do that, because now you have a service mesh, now you have control of the network, all these kind of things. And we're talking about Knative. There is a managed version of Knative that is Google Cloud Run, which is a managed version of Knative served as a part of the cloud, Google Cloud platform. And then you have Azure Container Apps and all those kind of things. And then one more thing that I would like to mention here is something called Keta. And Keta is kind of a fun thing. And Keta is, it stands for Kubernetes Event-Driven Auto-Scaling. So that's another way of scaling based on events and stuff like that. And if we go to Knative, it also has, so Knative has also two way of serving. So it has auto scaling can do like progressive rollouts. It can handle events. It has event integrations, all those kind of things. And then you can do serving or eventing. Serving will let you like control the traffic and do traffic splits and all this kind of stuff. Eventing will be more reacting on events and all those kind of things. Yeah, you're welcome, Hemal. So I'm seeing a comment here saying thank you for an interesting talk. And then Simon will said something similar as well. So thank you to all of you as well. I'm almost done, so I'll just finish with another slide where I have some. So this is a few links that you can follow and to find some things where I talk about cloud security principles. So things to think about when you do cloud development or cloud native applications. I have another talk that I do called 5 features talk or 5 features for your cloud native applications. This is a repository for that talk. I have another talk where I talk about yeah, I heard that about optimizing your Java or JVM applications. And that's the third one. So the third repository is about that. And then you can actually see how you can optimize things by just switching runtimes, using different libraries, using different techniques for things. And all that you should be able to go and look in the README files on that GitHub repositories. And if the easiest way to get hold of those, if you don't want to remember all those URLs, is to either take a picture of it now, or you can also go to rustam.no. That's a kind of a collection of all the links where I've put together, and you'll see it here on the slide here, or scan that QR code that you see at the bottom there. That will bring you to links to the site with all the links about where you'll find my GitHub, where you'll find my blog, where you'll find all the other things, because I kind of got tired of putting all the links and listing all the things, and then you can that's the collection of those. So and that's also, by the way, my Blue Sky handle as well, rustam.no. And the one you see on the screen there is my Twitter as well. So you'll find me online. You can ping me. Feel free to ping me, to follow me, and to ask questions online as well. But now I think we're a tiny little bit over time, over the hour that we had. And if you have some more questions, if you have some ideas, thoughts, things that you would like me to add to presentation, to the list of tools or list of requirements or things, anything really, I would love to hear from you. And I see some people saying, great content.
Yeah, lots of people here. Yeah, Rustan, lots of people here saying, thanks, Rustan. That was an awesome talk, and think it was a very interesting talk.
Thanks.
And then, yes, and thanks, Rustan. Thanks, Bruno, for moderating. So thanks, Michael.
Thanks to you, Bruno. Thanks for bringing all the comments on the screen and asking for questions and like commenting and helping me along the way in introduction. It's really, really great. Thank you so much.
Thank you. Yeah, so Jasper is gonna see you next week, right? In J Focus, right?
I'm looking
Johan is thanks, Rustan. Great content, right? Ronaldo, great talk. Thank you. Okay, cool.
Thank you so much. Thank you all. Again, let's meet somewhere at a conference somewhere. I will probably see each other soon, or if not, just ping me online if you can't wait for the next round.
All right, guys. So I don't see any more questions, Rustan. So I think that's everyone. You should go in and get Rustam's contact and information and all the links that he put here, and make sure that you can connect with him. One of the most important things that I think that's why I love those live conversations, right? I had quite some problems by doing live on Friday, right? But um, the live conversation allows us to have those conversations, and I think that everyone here should continue the conversation, right? Reach out. I see Jasper, for example, they're going to talk to you on J Focus, but everyone else, you should reach out to Rustan, connect with him on social media, and make sure that you keep the conversation going.
Feel free to ping me when you see me going to some event and you'll be there. Stop by, say hi. I mean, I will be happy to talk to you all.
Perfect. So thanks a lot, Rustan. It was amazing to have you here, and thanks for everyone for being part of the Java Champions conference. Right, this conference is run by Java Champions, organized by Java Champions. All the speakers are Java Champions, and all of these for you. Right. So thanks everyone. There was a question that I got today. How do I become a Java champion? And so just a quick answer here. A Java champion is a recognition for the things that you're doing, right? So, you don't do anything special to become a Java champion. You do things that improve your career, that make your career grow, and then people recognize you and turn you into a Java champion. Actually, there's one more question here from Ronaldo, right? So let's
I just saw it. I just saw it.
So,
yes.
Yeah. So Ronaldo asked, do you think multi-cloud is a must, or it's not a problem to be with just one specific cloud provider? What do you think?
Like I said, I don't think it's a must for a lot of use cases. It depends on your use case, depends what you're developing. So like very typical, most of the times, I would say there are two important use cases for that. One of them is you have very critical application that has to be online no matter what, and then you go multi-cloud, so you can actually again, multi-cloud is when you use several clouds and then you use some different or same offerings but on different clouds. So typically that would be very, very high availability requirements, maybe high or near presence requirements, where you would be like, you have to be so close to a closest point of presence of your cloud provider or providers, just because speed or something else. That's one. And the second one is where you would be choosing several cloud providers and picking and choosing several offerings from different providers based on, I don't know, availability, price, things like that, where it's cheaper to get something from one cloud provider and it's cheaper to get something else from another cloud provider. Then you can actually combine those. Sometimes it can be not even price, it can be just as simple as availability. Some of them have really, really cool graphic cards, or something that you can do machine learning on, and some of the providers might not have it. So it's really not a must in most of the cases, unless you're very price aware and you have enough usage that little change of pricing, or maybe bigger change of pricing, will actually matter to you. Or again, it can be just as complicated as requirements for availability and stability of your solution as well. Yeah, I hope it explains the idea.
And you mentioned that, right? Sometimes there's some things that only some providers offer. I remember using the past, for example, this provider that had Mac OS servers, right? That's not very common, right? And so sometimes you might need to go multi-cloud,
Exactly.
just to address your needs.
Yep. That's a very good point. Sometimes you just have, like, I don't know, Android virtual Androids. I don't know, something like that, right?
Yeah. Okay. Very cool. So thanks everyone. Once more, thanks everyone. Actually, Anisat is saying, great session. Thanks.
Thank you so much.
Yeah, Ronaldo said great talk. Thanks. Thank you. So thanks everyone. Thanks. Thanks for everyone that's organizing the JC conference. There's a lot of people behind the scenes. Ken is the guy that's kind of making us all do this, right? So thanks a lot, Ken, for doing it. So, and
Thank
thanks
you.
everyone for participating, right? So there's a few more sessions today, but today's the last day. So don't miss out the chance for you to talk with people in person. But always remember that every single talk has been recorded and you can go back and watch. And we have this several years of talks worth in the Java Champions Conference YouTube channel. Okay, so see you guys. Thanks a lot, Rustan. Amazing to have to be here. Amazing talk. Thanks a lot.
Thank you so much. Thank you for hosting.
Yes,
See
thanks
you
everyone.
all. Thank you all for coming and joining. Bye bye.